For the following graph, determine for which values of x equals a, the limit of x equals a of f of x exists, but f is not continuous at x equals a. Okay, so let's take a look at different points of interest here. So we're trying to find points where the limit at that point exists, and that means the limit from the left and the limit from the right agree. So here's one value of interest, -1. The limit from the left would be +3. The limit from the right would be +1. Those don't agree, so that limit does not exist there. So that's not a point that we're interested in. Here's another point where something's happening, so at 0. The limit from the left, however, looks like it might be going, it might stop at 4, it might go to positive infinity, but it doesn't really matter because the limit from the right is going to about 3. They don't agree with one another, so that limit would not exist either. Okay, and now we have another point of interest here at 1. The limit from the left, these values are approaching 1. The limit from the right, these values are also approaching 1. So the limit exists, but there's a discontinuity because the limit has to equal the value of the function there, and that's not the case because the limit here is 1. The value of the function is where this closed circle is at 2. So we have x equals 1 is a point here that qualifies. And I think that's it. We're looking for discontinuities, so that's all of the different discontinuities that exist. Next, we want to determine for which values of x the function is continuous but not differentiable. All right, so continuous but not differentiable. So all of these points here, those are not of interest to us right now because we're looking for points that are continuous. We just want a point that happens to be continuous but not differentiable. And that is this point right here. At a sharp corner, a function is not differentiable there. So what happens is, if you tried to define a tangent line, on this side, the tangent line would be sloped kind of like that. On this side of the point, the slope would be like this, and then at the point, well, which one do you choose? So there's two different options, so what we say is it's just not defined there. So at any sharp corner, the function is continuous because the limit from the left, limit from the right agree, and that's equal to the value of the function, but it's not differentiable. So the values of x for which this qualify are x equals